Okay, this is a nice and not so easy assignment. An ideal gas with Y is 1.4, occupies 4 liters and at 300 Kelvin degrees and 1.0 times 10 to the 5th pascals of pressure. It is compressed adiabatically to 1/4 to quarter of its original volume, and then it cooled at constant volume back to 300 kelvins. And finally, it is allowed to expand isothermally to its original value. How much work is done on the gas? So we have 3 points here. This is the 3 points. So first of all, we have V1 of 4 liters, T1 of 300 kelvins, and this is the pressure of the first point in the first point. And that is nice to have everything here. The second point, that is adiabatical, let's say, compression, obviously, to the 1/4 of that V1, and quarter of 4 liters is 1 liter. That is adiabatical motion. Then it's cooled, that means that Q is lost, but that is under constant volume. That means that V3 is equal to the V2, and that is the same 1 liter. Then that will be cooled to constant volume back to 300 degrees. So at the third point, that was almost 300 degrees. And then from point 3 to point 1, as you can see, there is the same temperature. That is a thermal process, of course. And then that expands thermally to its original volume. And then how much work is done on the gas in all this process? Okay, let us see here. So this is PV diagram. This is the pressure, this is the volume. This is the first thing. As you can see here, volume is 4 liters. Then we compress to the quarter of that volume. When we compress adiabatically, of course, the pressure will rise. What is the pressure P2 here? We don't know, but that is one thing that we will need, and we will calculate that. So we will need pressure here, and we will find temperature here in this point 2. Then we have here motion in the same volume, and in that motion here, from here to here, that is the same volume, temperature will rise. But as you can see, pressure will drop. Why? Because volume is the same, and the temperature is rising. Doesn't matter. So we will calculate everything. We have one V1, T1, and P1. Here we will calculate for adiabatic process from here to here what is T2, what is P2, and from, let's say, for constant volume process, isochoric process, we will calculate what is the V2. We have V2. We will calculate that is P2, and we will have all parameters here, here, and here, and then from there it's not too difficult to calculate the work. So let us see what is the first thing. So this is the first thing. This is the second thing to do. Now let's see what is the third thing actually to do. Third thing is to find every other parameters. So this thing we have here. Now, how to find temperature in second point, and how to find pressure on the third point. Temperature, pressure on the second, and pressure on the third point. So, what is this? This is P times V on gamma is constant. That means P1 V1 on gamma is equal to P2 V2 on gamma, but we on Y. This is not gamma, this is Y, this is what we have, that is 1.4. And we have that, and we calculate the pressure here. Now, from this, we can calculate what it is T2. Because this thing here is constant, P1 V1 divided by T1 is equal to P2 V2 divided by T2. And from there, we need to calculate what is the temperature on the second point. Very similar here. we'll calculate what is the pressure on the third point. Now we have all of these three parameters, and from there you could calculate the work in adiabatic process and in isothermal process. And then what is all that put together. From here you could do it yourself, or for complete written answer, please follow the link in the description. If you want more of this, please subscribe and tell your friends. Thank you. Bye.